I don't want you to be in your table of contents yet because I want you to listen about this part, okay? Next week, we have map testing, okay? We have 2 days of map testing next week. Map testing will be on Tuesday and Thursday, okay? This, Miss Morris's homeroom, will take ELA on Tuesday and math on Thursday, okay? My homeroom will take math on Tuesday and ELA on Thursday because we will be with whoever's testing for our subject, okay? There will be virtual kids in with your class, okay, in the computer lab. There will be some students in Mr. Starling's room, okay? And those days will be ELA on Tuesday, math on Thursday, okay? So, please make sure that you are preparing yourself, working on your Khan Academy. Make sure that if you've got a question about something, that you ask it, okay? If you go back through your journal and you have a question about something that we've gone over, you need to ask me, okay? Because if you don't and you wait for map testing day, you are going, that's too late, okay? You need to ask me now, all right? Because now, this chapter 7, we're putting a lot of stuff together that we've done all year long. So you may see something that you might need help with, okay? And if that's the case, you need to ask. All right, now I want you to turn to your table of contents. And I want you to add 7-2 equivalent ratios.
Bert, may I sharpen my pencil?
Yes. Did you go in Miss Morris's room? Sir?
Yes, ma'am.
And you need to go again. Okay. You need to see me at lunch then. You can go, but you need to see me at lunch outside. All right, we're on the same indicator that we were on yesterday. And our focus statement for today is at the top of the paper that you're putting in your journal today, and it says, I can find equivalent ratios. And that's what our goal is for today. We are going to use the same terms that we used yesterday: ratios, rates, unit rates, and we're going to talk about equivalent ratios. before we talk about what an equivalent ratio is, we're going to talk about what a basic ratio is, okay? So, what does the word basic mean?
Standard.
The same as everyone else.
If I talk about a basic pencil, what am I talking about?
Normal wood pencil.
Let me hold that. This is what Jenna says is a basic pencil. Who agrees?
Yes, I do.
Can I hold yours for a second? Is this a basic pencil?
No.
No. What kind of pencil is this?
Lead pencil.
It's a lead pencil. So basic means the simplest, okay? Right? Is that what we're saying? That's what we're meaning here, okay? A basic ratio is the simplest ratio. So anytime you're given a ratio and it asks for it in simplest terms, you need to write it like a fraction, okay? Because we're going to reduce it just like we did when we reduced fractions. So if I've got 24 to 30, what can I divide 24 and 32 by?
24 and 32.
Yep, I can divide both of them by 8.
Teachers, please pardon the interruption. At this time, will all the senior completers please report to the canteen for a meeting with Ms. Rhodes? All senior completers, please report to the canteen for a meeting with Ms. Rhodes. Thank you.
What about 4? What's 4?
Don't pull on that, I'll break it. All right, 24 divided by 8 is 3. 32 divided by 8 is 4. Okay, so now we have 3, 2, 4. Anytime you are finding equivalent ratios, you need to find the basic ratio every time, okay? If you don't find the basic ratio, you are going to struggle trying to find the equivalent ratios. Yes, sir?
Can't you do it divided by 4?
You could have divided by 4, but if we had divided by 4, 24 to 32 divided by 4, what's 24 divided by 4? 6 to 8. Can I divide 6 and 8? By something?
Yeah.
Yep, what can I divide those by? 2. So it would have been a 2-step process instead of a 1-step. Okay? Alright. So the next thing that we're going to talk about is what equivalent ratios are. Okay? What does the word equivalent mean?
Equal.
Equal. So, just like when we write basic ratios, and we write it like a fraction, so that we can simplify it just like we simplify a fraction. When we are writing equivalent ratios, we're going to do it just like we do fractions, okay? We're going to write it just like a fraction. We're going to figure out equivalent ratios just like a fraction. So, I'm going to write over here on the side just so that everybody can see. You have room right here to write. It's just that the people in the back, it's harder for them to see if I don't write over here bigger because the plexiglass has such a glare, okay? So, equivalent ratios are equal ratios that simplify to the same basic ratio. Equivalent ratios can be found on the same ratio table. So, we're going to do this as a ratio table, okay? So, there are 6 red pens to 9 blue pens in my drawer. So, we are going to do red to blue, okay? So, I'm going to come over here and I've got 6 red to 9 blue. And the first thing I told you, when we make equivalent ratios, what's the first thing we have to do? Find the what? The what?
Oh, the basic.
The basic ratio. What can I divide 6 and 9 by?
3.
3. 6 divided by 3 is 2. 9 divided by 3 is 3. Okay, now we are going to make a ratio table.
That technology didn't come for you.
What happened to the perfect straight lines?
I don't have it today. Alright, so we've got 2 red pens to 3 blue pens. Now, if I multiply by 2, what do I get? 2 times 2 is 4. 3 times 2 is 6. What if I multiply by 3? 2 times 3 is,
Oh, 2 times 3.
2 times 3 is 6. 3 times 3 is
9.
9. Okay. What about 2 times 4?
3, 4, 6, 8, 10,
8. 3 times 4 is
12.
12. Could we keep going?
Yeah.
Yes. Okay. But we're taking the first ratio right here, and you can see by my colors that we're multiplying by something different each time. Do you see that?
Was I supposed to write that down?
Yes, sir.
I wrote it down.
You should have had room to write it right here. But that's okay. It's fine. All right. The next thing, when we're talking about equivalent ratios, sometimes you are asked to compare ratios to determine if they're equal or not. Do you remember trying to determine if fractions were equal or not? Yeah. Okay. Y'all, it's the same thing. Okay? You're going to use the exact same process. So, right here, we have Mr. Elkins ate hamburgers on 4 of the last 9 days. Mrs. Patterson ate hamburgers on 16 of the last 36 days. Are these ratios equal? So, Mr. Elkins ate hamburgers on, I'm going to put E for Elkins, and he ate 4 out of 9. Can I reduce that any? No. I'm going to put P for Patterson. She ate 16 out of the last 36.
Yes.
Can I simplify that one? Yeah. What can I divide 16 and 36 by? 4. 16 divided by 4 is 4. 36 divided by 4 is 9. So, I've got 4 to 9 and I've got 4 to 9. Are those equivalent ratios? Yeah, they're equal. Okay, because equivalent means what?
Same.
Same. It means equal. Okay. Now, Miss Pinto has 12 red shirts and 15 blue shirts. Miss Paramore has 6 red shirts and 8 blue shirts. Are these ratios equal? So, I've got Miss Pinto, so I'm going to call her P.I. for Pinto. And she's got 12 red to 15 blue. Can I reduce that? Yeah, what can I divide 12 and 15 by?
3,
3. 12 divided by 3 is
4.
4.
15 divided by 3 is 5.
5. Very good. All right, now, Miss Paramore has 6 red to 8 blue. What can I divide 6 and 8 by?
2,
6 divided by 2 is
3.
3.
8 divided by 2 is 4.
So, here we have 3 to 4 and 4 to 5. Are those equal?
No.
No. So those are not equivalent, okay?
Equivalent? I think not.
Wait, so you're trying to get even more plexiglass on the side?
Yep.
That's what it's like in Miss Lovelace's room.
Mm-hmm. All right. I don't want you to write anything yet because I want to read this to you, okay? Natasha made raspberry punch for a party by mixing 9 fluid ounces of fruit punch, 3 liters of soda, and 6 scoops of raspberry ice cream. Halfway through the party, the punch bowl was empty. if Natasha only has 6 fluid ounces of punch left, how much ice cream does she need to make another batch of punch? So, we're comparing our fruit punch to ice cream. So up here it tells us how much fruit punch do we have? 9 of the punch to how many scoops of ice cream? 6 scoops of ice cream. Okay? What's the first thing we have to do when we're figuring out?
Make the 6 a 1.
If we're finding a basic ratio, we've got to reduce it as far as we can. So what can I divide 9 and 6 by? 3. 9 divided by 3 is
3.
6 divided by 3 is 2. So we've got fruit punch is 3, ice cream is 2. And how much does she have?
6.
She's got 6 of the punch, okay? So how do I get from 3 to 6?
Times 2
Times 2. So 2 times 2 is 4. So let's go back to the question. If Natasha only has 6 fluid ounces of fruit punch left, how much ice cream, and I know I'm missing a C, does she need to make another batch of punch? We want to know how much ice cream. So how much ice cream does she need?
A lot. Oh,
She's got 6 ounces of punch. How much ice cream does she need? She has 6 ounces of punch. How much ice cream does she need? 4 scoops. 4 scoops of ice cream. All right, now I want you to pick your pencil up. Nico is having a pizza party. 2 large pizzas serve 9 people. How many large pizzas should she order to serve 36 guests? I want you to figure out how many pizzas she needs.
You have to use a chart.
You do not have to use the chart. If you can do it without the chart, you don't have to use the chart.
So what?
The ratio table that I drew for you up here.
Wait, are you gonna make a poster about it? Like the ratio table?
That's the ratio table we were just doing.
A poster, like how she has all those. I don't make those. I want the list. It's 2 large pizzas.
Your pages aren't going to be right. You should take that on one page. You better find it. I'm waiting.
Where's the paper like this?
I just gave it to you. Go look for it and find it.
How many pizzas is a large pizza?
So how many pizzas does she need?
She needs 8.
She needs 8 pizzas.
Eight pizza.
8 pizzas.